There are several kinds of common addition reactions, and these are chemical reactions that often happen in biological systems also. We're going to be looking at very simple examples out of organic chemistry. Basically, an addition reaction involves the addition of a substance across an alkene. Remember, that's a substance with a double bond. So if I have the simplest alkene, that would be ethene, and I can add substances such as bromine to ethene to give me a 1,2 dibromoethane. And the point is that any double bond can add bromine or in fact, any of the halogens in this way. If you'll notice what's happened across the double bond, you have broken one of the two bonds of the double bond and also broken a BR-BR bond. So you've broken two bonds, and you've made two new bonds between the carbon and the bromine. So each carbon ends up with a bromine hanging on it. Basically, all addition reactions involve two atoms being added to the two atoms participating in the double bond. So, for example, a very common one also is the addition of hydrogen gas across a double bond. And notice here would be an example of adding, and I'm writing the two extra hydrogens that now added. That would be ethene turning into ethane, because I've simply saturated the double bond by adding hydrogen. Hydrogen halides also add across a double bond. So, for example, I can add something such as, say, HCl across ethene, and notice in this case I get mono. That's not an H, that's a Cl. I get chloroethane. Notice I don't need a number to signify where the chlorine is in this example, because there's only one possible place where it could go. Also, very importantly, I can add water across a double bond. And in this case, the way we view water, I know we always write it as H2O, but we think of water as being H bonded to OH. When we talk about acid-base chemistry, you'll see that this is a very common way to think of water. So what happens here is we add an H from the water and an OH from the water across the double bond to give me now ethanol. And notice this H and this OH are the atoms that actually added. This addition reaction is also interesting because its opposite reaction, an elimination reaction, also occurs with alcohols. It doesn't happen with the hydrogen halides so much, but I can take a molecule such as cyclohexanol. Notice that's cyclohexane with an alcohol, so I simply call that cyclohexanol. And if I treat this in a strongly acidic environment, I can produce cyclohexene and water. Refer to your textbook here, which gives you a very clear demonstration of this. But what you've really done here is you've removed an H from one carbon atom and an OH from the other to make the HOH, the water, and now you form the double bonds. So double bonds can be formed in elimination reactions, and they can be broken or added across in addition type reactions.